Hello and welcome to this new video on the IUPAC nomenclature of cycloalkenes and cycloalkynes. In the previous video, we looked at the naming of cycloalkanes, and now it's the turn of cycloalkenes and cycloalkynes. So let's start with the rules of naming. The first thing that we need to do is to determine the number of carbon atoms in the cycloalkene and then name the cycloalkene as the name of the alkene with the prefix cyclo to it. So determine the number of carbon atoms in the cycloalkene, name the alkene and add the prefix cyclo to it. For example, if I have, let's say, a 5-membered ring and I have a double bond here. Now this is going to be a 5-membered ring, 5 carbons, so that is pentene. And since it is a ring, I'm going to call it cyclopentene. And similarly, if you have any other size of ring, let's say you have cyclobutane with a double bond, you call it cyclobutene. 4 carbon atoms, double bond, butene, and cyclo to it. Now here, remember, we do not have to talk about the number, the position of the double bond, because it is automatically accepted that even whenever you number it, the carbon having the double bond will always get the value 1. Now, what happens if along with the double bond, you have a substituent? If you have a substituent along with the double bond, numbering is required because we need to know where the substituent is present in relationship with the double bond. So the rule of naming such a compound is that you always give number 1 to one of the double bonded carbon atoms and number 2 to the other doubly bonded carbon atom. So if for example I have something like this, I have this, let's say I've got a methyl group here. Now one of these carbon atoms, this one or this one, is automatically going to get 1, and the other of the double bonded carbon atoms will automatically get 2. So if I number this as 1, this becomes 2. Or if I number this as 1, this becomes 2. Now that is a given. So that is something which we always need to follow. Now comes the question, which is 1 and which is 2? For that, you need to understand that if I give this as 1 and this is 2, then automatically this becomes 3 and this becomes 4. Now, if I were to do the other way around, if I were to give this as 1, this is 2, this is 3, then this becomes 4. Now, in this particular case, it doesn't really matter. But if it matters, if the numbering changes, then the substituent, this carbon, should get the least possible value. So the second rule is, if there is a substituent, then locant numbers have to be given by giving one of the carbons with the double bond as 1 and the numbering done such that the other doubly bonded carbon atom gets 2 and the locant gets the least possible number. The locant number for the double bonds are again not mentioned because we have automatically given them 1. So the rule already states that they have to be given 1. So we do not state the position of the double bond in this particular case. But remember, this is the situation when there is only one double bond, only one multiple bond present here. So let's look at some examples. Look at this one. Again, the way we go about in this video, I want you to pause the video now. I want you to number it. I want you to name this compound, and then you can play the video again to check whether your answer is correct or not. So here, I'm going to give number 1 to this carbon atom, this one, number 2 to this one, number 3 to this one. So it becomes 3 methyl cyclopentene. cyclohexene. I don't have to write cyclohex1ene. Now, what would have happened had I done the numbering the other way around? If this was 1, then this would have to be 2. You can't give 2 to this one because if this is 1, the other doubly bonded atom has to get 2. This is 3, this is 4, this is 5, and this is 6. Then I would have had 6 methyl cyclohexene. And we always must give the substituent the lowest possible value in this particular case. So this is the way the numbering is done. So this is the numbering. Let's take up one more example. Now I'm going to have two substituents and let's see what happens. Now if the ring is substituted by more than one group, then all the rules applicable for naming an alkene is followed. Again with the rules saying that the doubly bonded carbon must get 1, the other doubly bonded carbon must get 2, and the first locant should get the lowest number. And in such an event, if there is a choice in numbering, then again all the rules of alkenes are followed. For example, if the ring is substituted by more than one group, then all the rules applicable to the alkenes are followed except that the locant number of double bond is not mentioned. Look at this one. Pause the video, number it, name it, then check. Now here I have two options. I can give this is 1, this is 2, this is 3, this is 4, this is 5. Now what I'm going to do is I'm going to change the color of my pen. So let's make it a little bluish. Now if I were to give this is 1, this is 2, this is 3, this is 4, and this is 5. Now remember, my double bonds are getting 1 and 2 anyway. But if you look at the red numbering, the first substituent comes at 3 and the second substituent comes at 5. If you look at the blue numbering, the first substituent again comes at 3 and the second substituent again comes at 5. So now there's a choice in numbering. So when there's a choice in numbering, since both numbering gives me the same numbers, then I must use the same rules that are applicable in naming a typical straight chain alkene, which says that you must give the lowest number to the substituent that is going to come first alphabetically. So it's going to be chosen alphabetically. So now this particular substituent is methyl. This guy sitting here is propyl. And we know that M comes before P. So methyl is preferred. So methyl should get 3 and the propyl should get 5. So this is the numbering. So how are we going to see it? It's going to be 3 methyl, 5 propyl, cyclopentene. Again, we don't need to specify the position of the double bond. Let's try one more. Now I'm going to have 3 substituents. Pause the video, check for yourself what the answer would be, and then play the video. So I'm going back to my red color, it's visible easily. Okay, now what do we do? Which is 1, which is 2, which is 3? Let's try all possibilities. 1, 2, 3, 4, 5, 6. So where do I get my substituents? 2, 4, 6. So let's change my ink color. Now let me use black. Now another option is I could use this is 1, this is 2, 3, 4, 5, 6. And now you'll notice that in the very first carbon I have a methyl group. So one substituent comes at 1. Then I have the next one coming at 3. Look at the black numbers. Then comes 5. And you must look at the lowest value at the first point of difference. So if you compare 2 and 1, 1 wins. So therefore, we should be using the black numbers, not the red ones. So in this particular case, the numbering is done like this. So now let's write down the name. So the substituents are methyl, we have ethyl, and this guy sitting here is isopropyl. So alphabetically, ethyl should come first, isopropyl should come second, methyl should come third in naming. So this is going to be 3 ethyl, 5 isopropyl, 1 methyl cyclohexene. So that's the way this particular thing is going to be named. Now let's figure out a situation where we're going to have more than one double bond in a ring. So if the ring contains more than one double bond, then the numbering is done in such a way so as to give the lowest number to both the double bonds. Again, remember, if one of the double bond is given 1, the other doubly bonded carbon is 2, and then we go in that particular direction, clockwise or anti-clockwise. Say for example, if I have a 6-membered ring here, I got a double bond here, I got a double bond here, and I need to number this. Well, I can start from maybe here 1, 2, 3, 4. So what do I get? I get 1 as far as the double bonds are concerned, and I get the next double bond at 3. So let's try one more strategy. Let's number this as 1, 2, 3, 4. I still get 1 and 3. Let's try one more. How about naming this as numbering this as 1? If this is 1, automatically this becomes 2. Now I got to take it clockwise. 3, 4, 5, 6. Doesn't make sense because one is at 1 and the other is at 5. So the numberings have to be done in such a way where one of the carbon having the double bond is 1, the other doubly bonded carbon gets 2, and the next double bond should get as less a number as possible. So if you have this kind of a situation, this is the way you number it. Now let's take a situation when you have a double and a triple bond together. If the ring contains one double bond and one triple bond, then the numbering is done in such a way so as to give the lowest possible number to the double bond and then the lowest possible number to the triple bond. So again, let's take the same example. Uh, of course, I would need a bigger ring because smaller rings do not suppose a triple bond. So, but let me just for the sake of example, give you a situation like this, a triple bond here and a double bond here. How do I number this? Well, 1, 2. The double bond should get 1. The other doubly bonded carbon is 2, 3, 4. So I get 1 and 4. Now I'm not supposed to number the triple bond as 1 when there is a double bond present. And I could not have numbered this double bond as 1 because if I did that as 1, then this is 2, then my triple bond gets 5. I get 1 and 5. So I need to choose 1 and 4. So that is the way it proceeds. Now let's complicate the things a little bit more. What happens if a ring contains more than one double bond and perhaps even more than one triple bond? Then the numbering is done in such a way that you must give the lowest number to the double bond And the next multiple bond should get the lowest number irrespective of whether it is double or triple. And then the lowest number is according to the next multiple bond and in that order. But in case, let us say for example, there are two double bonds and one triple bond. And I am able to get the same numbers. I'm able to get, I give one to one of the double bonds, two, and let's say I get one for the first double bond. And if I number the triple bond next, I get three. And if I take the double bond next, I get five. And let's assume that if I number one of the double bond as one, the other double bond is three, and then the triple bond gets five. So if the numbering is same, then we will prefer to give both double bonds the lowest number. But if the numbering is not same, suppose I get 1, 3, 5, whereas this is double, this is triple, and this is double, and I get 1, 4, 6. Let's just assume that. And this is double, double, triple. I would prefer this one, lower number. And I'll give you a couple of examples for you to check this particular rule. So the ring contains two or more double bonds and triple bonds. Then the numbering is done in such a way so as to give the lowest possible number to the double bond and the other multiple bond, irrespective of double or triple bond, numbered such that lowest number is accorded to the next multiple bond. And only when there is a choice in numbering, then the lowest number should be given to the double bond over a triple bond. So let's take two particular examples in this. They're going to look very complicated, but don't worry. Follow the rules, you'll be able to name it correctly. Pause the video, name it, number it first, name it, then check. Now, whom do I give one? Obviously, one of the double bond has to get one. So let's try all possibilities. I get 1, 2, 3, 4, 5, 6. So what are the numbers I'm getting? 1, 3, 5. And this is double, double, triple. Okay, so let's erase this and try something else. Um, what if I number this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the second possibility I get is 1, 3, 9. This is double, double, triple. Makes absolutely no sense. And I just can't start with 1 as a triple bond. So that's not going to work. So the only way in this particular situation is to go for the earlier numbering of 1, 3, 5. So the numbering is done like this. Now I deliberately chose a 10-membered ring because only a 10-membered ring or a very higher membered ring can have a triple bond in it. Anyway, now let's try to name this. Now remember your substituents also. And we never consider the substituents. Substituents have to be considered only if numbering of the double bonds and triple bonds is similar in several forms. Then we'll try to give the substituents the lowest value. So I got a methyl. This fellow is a methyl. This is a methyl. This is an ethyl. What do you think this fellow is? This is isobutyl group. So ethyl comes first, isobutyl comes next, methyl comes next. So it goes like 8 ethyl, 10 isobutyl, 7 methyl. Now, this is the crucial plot. Now forget all the substituents. Now just look at the ring. It is cyclo deca, and the reason I'm using the deca A is because there are more than one double bond. Now I have to mention the position of the double bond. 1, 3, diene, and I'm not going to use the E of the ene because the next is going to be ein, 5, ein, because it sounds like a vowel, and this we've already discussed before. So the name is this. Big name. So now let's try one more. Pause the video, number, name, then check. So let's see how we're going to number this fellow. Let's try with this. I take this as 1, 2, 3, 4, 5, 6, 7, 8. My double bonds are at 1, the first double bond, then the next multiple bond, triple, which is 3, and the next double bond is at 6. Now let's number it in a different way. Let me number this as 1, 2, 3, 4, 5, 6, 7. Now remember, in the previous case, in this 136, this was double, this was triple, this was double. Now 1, which will always be double, of course, 4, which is again double, 6, triple. Now look at these two. In one of them, the triple is 3, the double is 6. The other is double is 4 and the triple is 6. Now here we don't have to even look at what is double and triple. We just look at the numbers. 136, 146, which one is going to prefer? It's automatically going to be 136. So out of this particular numbering, we are having 136. Of course, there are a lot of other possibilities of numbering, keeping this as 1, 2, 3, 4, 5, 6, 7. This is even worse. So because the 1 I get 4. The moment I get 1 and 4, forget about the rest. It's going to be 1 and 3. So there's only one way of numbering this, and that is going to be this. And there are so many substituents. So let's now look at the substituents. You got 2 methyls. What is this guy? This is allyl. What about this fellow? You've studied this in alkanes. It's tert butyl. What about this fellow? Ethyl. So alphabetical order. Well, allyl always will win A. In tert butyl, remember we never look at T, we look at B. So tert butyl will be the next one to go. Then ethyl, then methyl, and then the name. So let's get this right. So this is going to be 1 allyl, 8 tert butyl, 7 ethyl, 5 dimethyl. Now comes the important part. Cyclo octa 1 7 sorry 1 6, not 7, because the numbering was done this way. 1 6 dien 3 ein. Goes like this. So this is how you name cycloalkenes, cycloalkynes along with substituents. If there is any point that you have missed, anything that you want to check back, please go through this video as many times as you want and ensure that you get it right. And if you have any questions still, if you have any particular molecule of this particular type that you're not able to name, of course, remember, I'm not using any functional groups here. So this is particularly only for cycloalkenes and alkynes without any functional groups. So if you have any question regarding this particular type of molecules, please drop those questions in the comments below. I hope this video was responsible for making you understand. I hope you were able to get what you really wanted. Thanks for watching.